Okay, so in case you need some help answering these questions, I'll start you off. The first one says, how does the number of electrons change as you move from left to right across a period? Well, if you look at what they're referring to this. Yes, so it's asking you what happens to the electrons as you go from here to here, here to here, here to here. If you notice, the electrons tend to what? You have one right here, you have two right here, 3, 4, 5, 6, 7, 8, 9, 10. So what happens to the electrons? The number of electrons increase from left to right. Second question, what do all the atoms group 1A elements have in common? What do they all have in common? And remember we said that if they're talking about a column, they all have something in common. That something in common is the same number of valence electrons. Okay, so they have now list 3 things that all atoms of the elements in period 3 have in common. So when we talk about period 3, we're talking about row 3. Yeah, so that means we're talking about sodium through argon. One thing that they have in common is that they have how many rings? Yep, that's right. They have 3 rings. So 1, they have, and we're going to name them properly, 3 shells. And 2, it's just not something so obvious or not something that we have been looking at. But if you notice, they all have 2 electrons in the first ring, yeah, or in the first shell. So that's the second thing they have in common. And then 3 is they have 8 electrons in the second shell. Okay? So that means, in generally speaking, that their core electrons are all similar. Yes, they all have the same number of core electrons. The only thing that's changing is the number of valence electrons. And then I think you should be able to do 4, 5, and 6 without a problem. For 6, you will need a periodic table, so make sure you get one. Or you just look one up on the internet. It's not that much of a big deal. And then you should be able to do 8. And then for number 9, number 9's a tough question. One of the things is that when we start looking at shells, yes, we said, oh, well, how come we got shell 1, you have 2, 8, shell 2, you have 8 electrons, shell 3, 18, and shell 4, 32, and shell 5, and so on. And then that was the question that that was the idea that I was referring to when we were here in calcium and potassium. If you notice here in the second shell, we have 8 electrons, which fulfills what we just said earlier. But in the third shell, it's maximizing the number of 18 electrons. But then you say, well, how come we have only 8 and 8 right here? But all of a sudden you go to gallium, and gallium has all 18 in the third shell. Yeah? And that's the question that they're asking. Why is it that if you're in calcium, you have 8 electrons in the third shell, but all of a sudden you jump to gallium, and then you have 18 electrons in the third shell? So what happened? That's what they're asking. Okay, see if you can figure that one out. And I think you should be fine for the rest. Make sure to finish by the end of today, and turn it into the sub. Thanks.